Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have x cubed by x minus 1 into x minus 2, right? So what we've been given is dy by dx and we've been asked to find y. So my y is nothing but integral of the given expression, right? So I have integral of x cubed dx divided by x minus 1 into x minus 2. I will have to reduce y to a much simpler expression whose antiderivative I know from first principles or any of the rules slash identities I've learned so far in integral calculus, right? So I'm going to keep y aside for a minute and let's pick up our expression given to us and see how we can simplify this further, right? So there are multiple ways of solving this problem. Look at this particular expression. We've got x cubed by x minus 1 into x minus 2. I know that the degree of the numerator is greater than the degree of the denominator, so I cannot directly resolve this problem by partial fractions. So you can also do this problem by polynomial division, but I'm going to solve it in a slightly different way. And let's take a look at how I'm solving this. So I'll pick up this expression and for a minute I'm going to keep x cube aside, and if I keep x cube aside I'll have 1 by x minus 1 into x minus 2, right? And resolving that particular expression keeping x cube aside is not very difficult, right? You know how to solve it, and I request you to take a look at my earlier videos. So I'm going to keep x cube aside and I can rewrite my 1 by x minus 1 into x minus 2 as 1 by x minus 2 minus 1 by x minus 1, right? So this is what I get. And now that I have all that I've done is keeping x cube aside, I've resolved 1 by x minus 1 into x minus 2 using partial fractions, right? Now, step 2, what I do is actually bring in the x cube into the respective expressions, right? Remember, folks, we have two expressions. We've got 1 by x minus 2 expression, and I've got a minus 1 by x minus 1 expression, right? So I'm going to bring my x cube into each of these expressions and treat them separately for further simplification, right? So my next step would be x cubed by x minus 2 minus of x cubed by x minus 1, right? So there we are. So now I know that I have an x minus 2 in the denominator in expression 1, and then I have an x minus 1 in the denominator in expression 2, right? And I want you folks to connect the numerator with the a cube minus b cube formula, right? So what is my a cube minus b cube formula? It is a minus b into a square plus ab plus b square, right? Now what I'm going to do is I'm going to figure out a way to eliminate the x minus 2 in the denominator and the x minus 1 in the denominator of the second expression, right? And how can I do that? So the way I do it is I can rewrite my x cube in the first expression as x cube minus 8 plus 8 divided by x minus 2, right? And then in the second expression, I know that I can write my x cube by x minus 1 as x cube minus 1 plus 1 divided by x minus 1, right? So I hope you folks are with me. I've not changed the expression. In expression 1, what I'm doing is I'm adding and subtracting by an 8. And in expression 2, I'm adding and subtracting by a 1, right? And why am I doing it? Because my expression in the denominator with respect to expression 1 is a 2, right? X minus 2. I know that my 8 is nothing but a 2 cube. And in the second expression, I have an x minus 1. I add and subtract by a 1 because I know that 1 cube equal to 1, right? So I've highlighted the first expression in yellow. The reason I've done that is I'm going to decompose this further. So I hope you folks are with me. What I've done in decomposition is I've combined x cubed minus 8, and let me highlight it in a different color, say green. And then I'm treating the other 8 separately. So when I decompose this, I get an x cubed minus 8 divided by x minus 2 plus 8 by x minus 2, right? And I'm going to repeat the same thing for the other expression, right? So the way I'm going to do this is very similar. I combine x cubed minus 1 right? I decompose that given expression as x cube minus 1 by x minus 1 plus 1 by x minus 1, right? And remember, folks, I have a negative sign out there. So what happens is the entire expression has becomes minus of x cube minus 1 divided by x minus 1 minus 1 by x minus 1, right? So now uh, I'm going to look at each of these expressions, right? The reason I'm highlighting 8 by x minus 2 and 1 by x minus 1 in green is because I know the antiderivative of these expressions, right? Because we have done them in the past. I know that I have reduced a part of this particular expression to a format whose antiderivative I know from first principles. So I'm highlighting those two expressions in green. And then I'm left with these two expressions, x cube minus 8 by x minus 2, x cube minus 1 by x minus 1, right? So what's the job in hand? The job in hand is to eliminate the x minus 2 in the denominator and simplify this expression, right? So I'm going to apply the a cube minus b cube formula to this particular expression. A cube minus b cube equal to a minus b into a square plus ab plus b square, right? So in the first expression, my a is x and my b is 2, right? And in the second expression, x cube minus 1 divided by x minus 1, my a is x and my b is 1, right? So I'm going to expand this using this particular formula, and this is what I get, right? My first expression becomes x minus 2 into x squared plus 2x plus 4, which is my x cube minus 8. And then my second expression, which is x cube minus 1, becomes x minus 1 into x squared plus x plus 1, right? And the two expressions which I've highlighted in green, I've just parked them aside because I don't think I will be doing any further simplification with them. Now I know that I have an x minus 2 term in the denominator. I can cancel it out with the x minus 2 term in the numerator of expression 1, right? So which means my x minus 2 gets cancelled in the first term, and similarly I have an x minus 1 term in the second part of the expression. I can cancel out the x minus 1 out there as well. Notice that I've highlighted these expressions in yellow. So once I cancel, I know that I have removed the denominator in these two expressions, and I can see that my first part becomes x squared plus 2x plus 4, and then my second part, post cancelling out that x minus 1, becomes an x squared plus x plus 1, right? I notice that my x squared will also get cancelled, and for a minute I don't touch the other two expressions, I write them as they are. And in this particular expression, I notice that my x square will get cancelled out, and I'm left with 2x minus x, which is x. And then I'm left with a 4 minus 1, which is a 3. So I will get an x plus 3 plus 8 by x minus 2 minus 1 by x minus 1, right? So now I know that I've reduced this to a much, much, much simpler expression, right? Now, do I know the antiderivative of x in 3? The answer is yes, I know the antiderivative of x in 3. It's it's something very simple, and I've highlighted the other two expressions in green because I know their antiderivatives. Now I'm in a position to highlight the entire expression in green because I've reduced it to the simplest format whose antiderivative I can figure out very easily, right? So there we are. And let me go back to y, my y, which is integral of x cubed dx by x minus 2 into x minus 1, becomes a lot more simpler expression right now. So let's rewrite our y using the expression what we arrived at just now, right? So I have y equals integral of x plus 3 plus 8 by x minus 2 minus 1 by x minus 1 dx, right? So let's put that out inside the bracket. Now I go to the next step and I can apply the sum rule of integration. My integral of the entire expression becomes integral of each one of those expressions inside, right? So I have y equals integral of x dx plus integral of 3 dx plus integral of 8 dx by x minus 2. And then I have a minus of integral of dx by x minus 1, right? There we are. I don't think this is very complex from here on. So I know that my y integral of x dx is nothing but x squared by 2. We will reserve the constants towards the end. Let's simplify. Let's figure out the antiderivative for each one of these expressions first. So my first expression becomes x squared by 2. Then I have an integral of 3 dx, which is nothing but 3x. Then I have integral of 8 times, I can pull out my 8. Integral of dx by x minus 2 is nothing but 8 times ln of x minus 2, right? And if you've not understood how I'm arriving at this, I request you to take a look at my earlier videos, 248, 249, 250, right? And then my final integral is just minus 1 times integral of dx by x minus 1 is also something very similar, right? Which is nothing but a minus 1 times ln of mod of x minus 1, right? And minus 1 into ln of mod of x minus 1 is nothing but minus ln mod of x minus 1 plus c. I add my constant towards the end because each one of these has individual constants. I combine all of them and represent it as one single constant, which is c, right? So there we are. My answer to this problem is y equals x squared by 2 plus 3x plus 8 times ln of mod of x minus 2 minus ln of mod of x minus 1 plus c. Can I do any further simplification? The answer is no. So let's highlight our final answer in pink, and there we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.